All right, so today we are going to be determining the focus and directrix of a parabola. We're going to be writing quadratic equations given any of these three features, where a focus, a directrix, and or a vertex. All right, so a parabola is the set of all points in a plane that are equidistant, so that same distance from a fixed line called the directrix, and a fixed point which is not on the line called a focus. All right, so writing equations in different forms this time today. So what we've been doing, we've had vertical parabolas where they open up or down. Today we're going to introduce a new way to write these, but also introduce horizontal parabolas which open right and left. All right, so vertical is up and down. So your vertical parabola is going to either open up or down. So vertical opens up or down. Now, when we're opening up or down, what we've learned, these are the parabolas that we've done, the x has always been squared, right? So guess what? Equation looks different. Look how your x still has the squared with it. So that's really how I still know which one, because this one is going to have the y, which one has the x or the y squared. Opens up or down, that's what we're used to, which our x is usually has been squared, so your x is going to stay squared. All right, and the parabola, we still have a vertex. That's what that V is for. Your vertex is still your HK. All right, nothing changes with that. Your vertex is still your HK. Your H still goes with your X. Your K still goes with your Y. So same exact. Nothing changes with that. What goes with the X and the Y. All right, something different though, we have this plus or minus for P. So what in the world is P? What is even going on with this picture? All right, so we have our vertex. We have what we said is called the focus. So if you look down here, vertex HK, P is the distance from the vertex to the focus. So from the vertex to the focus. So from here to here has a distance of P. And also from the vertex to the directrix, here to here, also has a distance of P. Yes. 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 Now, we're not really going to be graphing. Like you don't have any where you have to actually graph the whole thing on your, really on your notes or your homework. But I'm going to, just as a little additional, when we do our notes today, I am going to just finish out the graph. So with that said, and also this kind of explains what is this 4P business. So if you look here, P is 2. 1, 2. If you look from here to this point, so here to here, that is 1, 2, 3, 4. Well, for this graph, if P is 2 and this is 4, this is going to be 2P. So from your axis of symmetry to point on the vertex. Same thing on this side. This is 2P. Well, 2P plus 2P, so from this point to this point would be a total of 4P. That's where your 4 comes into play. And where the plus or minus comes in. So if it opens up, your P is going to be positive, or this is going to be a positive 4P. If it opens down, it's going to be a negative 4P. Any questions so far? All right, let's look at horizontal parabolas. Horizontal is left to right, or right to left. So horizontal, right to left. If you notice here, so if it opens left to right, your y value is what is squared. Notice it changes position, and I'll show you later that it doesn't really matter which side the square is on. But your 4P, your plus or minus 4P, is always going to go with the variable that's not squared. Your vertex here is still your HK. Your x value of the vertex, your h, still matches with the x. Your y variable of the vertex, your k, still matches with the y. That doesn't change. See how on both of them, the k is with the y, the h is with the x? That's not going to change, ever. This same thing, it just whether it opens left or right. So from the vertex to the focus, this is still a distance of P. And from the directrix to the vertex is still a distance of P. And then here to the edge of the vertex here from the focus to this point, this here is still 2P, and then same thing on the other side, it's still 2P. And then where the whole thing, that whole distance from both of those points is your 4P. So whether the 4P is positive or negative. So if it opens to the right, I guess I could write this down. If it opens to the right, that was horrible, it's going to be a positive 4P, but if it opens to the left, it's going to be a negative 4P. It's going to have the negative out in front. And same thing with the vertical parabolas. If it opens up, it's going to be a positive 4P. Think about when we did it in class, the first 2 times we did it, or first 2, 3. If it opened up, my A was positive. And if it opened down, my A was negative. So this is going to be a negative 4p. Any questions? All right, let's flip it. All right, example. So it says you may want to use the graphs as a visual to find the vertex and the p-value. All right, write the quadratic equation given a focus of 3, 2, and directrix of y is equal to 0, and we're going to state the direction of opening. So coming to my graph, I am going to graph this information. We have a focus of 3, 2. So I'm going to go over here, graph it. And I'm going to label it F. Now I have a directrix of y is equal to 0. So my directrix of y is equal to 0 is right here. All points here going to have a y value of 0. So here's my directrix. At y is equal, sorry, y is equal to 0. Now, if my directrix is here and my focus is here, how is this going to open?
Between those.
Yes, so your focus, if you go back, your focus is always like inside of how it opens. And your directrix is always like below or to behind it. So if I go back and look at here, if this is my directrix and this is my focus, it has up. So it's going to open up or upward. I'm cool if you just say up. All right, so I have my focus, I have my directrix. If we go back and look, if you see here, your vertex is in between your directrix and your focus. All right, it's directly in between. So let's just make note of that. Vertex is in between the focus and directrix. And because it's in between, it's equidistant. So it's same distance, same. All right. So in order to write the equation, we have to know what our vertex is. If it's in between the directrix and focus, so between the directrix and the focus, they are 2 away, so the vertex is going to be 1 away. So this is my vertex right here. So I can get that ordered pair at 1, 2, 3, 1. Now, your value for P is the distance between the vertex and the focus, or the vertex and the directrix, which is just 1. All right, now before I write the equation, so if it's opening upward, it's going to be in the form. So if it opens upward, it's going to be where my x is squared. So it's going to be x minus h squared is equal to, now because it opens up, my p is going to be positive, so 4p. And then y minus k. Now, I know it doesn't say that we actually have to graph the whole parabola, but just so you can kind of see what really would this look like. If here is the focus, if you go back to, we look at the first page, from the focus to one of the points here is 2p. So if my value for p is 1, 2 times 1 is 2. So from the focus, we would just go over 2 in both directions. I have 2 points or 3 points I could draw. Like, that's how your parabola would look. So now in your equation, so x, now we want to put the vertex in. So x value of the vertex, your h value is 3, so x minus 3 squared is equal to, well, if p is 1, 4p then is 4. 4 times 1 is 4, so this is 4 times y minus k value of the vertex is 1. If you need to kind of color code where things came from, so your h, x value of the vertex, 3, your k, y value of the vertex, and then your p, that's what we had from here to here. Any questions? All right, next one. We're going to write the equation given a focus of -6, -8, and a directrix of x is equal to -4. We're going to state the direction of opening. So let's plot this information. So -6, -8. So this is my vertex. Oh, no, that's my focus. Why not? This is your focus. Focus. I have a directrix of x is equal to -4. So if I go over to -4 on my x, 1, 2, 3. It's going to be up and down. So So that's at x is equal to -4. That's your directrix. So if that's my directrix, this is my focus. How is this going to open? It's going to go, yeah. It's going to open to the left. So it's going to, if it's going to open to the left, which variable is going to be squared, x or y? The y. So it's going to be in the form y minus k squared. And if it opens to the left, is my p going to be positive or negative? Negative. So negative 4p times x minus h. Remember, your h and k always stay with the same variable, the x and the y. K is always with y, h is always with x. All right, now I need to find my vertex. So if I have my directrix and my focus, your vertex is halfway in between. So it would be right here. So that ordered pair would be -1, 2, 3, 4, -5. Why am I writing things backwards? -5, and -8. All right, so what would my value of P be? 1. So that was my vertex. P would be 1. So that means for a -4P, so -4 times 1, which is a -4. So my equation, y, so k, value of the vertex, -8, so y minus a -8, so y plus 8 squared is equal to, well, -4p is -4, times x minus h, well, your h is -5, opposite of -5 is a +5, so there's your equation. Any questions? Highlighting just if you need to see. Any questions? I guess I could have graphed the whole thing too, but it's okay. All right, let's look. All right, write the equation of the parabola given the focus 4, 1, and the directrix of x equal to -2 is graph below. So I have my graph right here. Directrix, focus, it actually already went ahead and plotted my vertex. So how is this going to open? To the right. If this is my vertex focus, it's going to open this way. So it opens right, it's going to look like that. So my P, is it going to be positive or negative? Positive, so we're going to have a positive 4P. So if it opens to the right, which one is going to be squared, my x or my y?
Your y.
My y. So y minus k squared is equal to that positive 4p times x minus h. Now, the graph already gave me my vertex at 1, 1. So my value for P, so like from your vertex to the focus, so this is a distance of 1, 2, 3. So P is 3. So 4P, 4 times 3 is 12. So just going to put in our stuff in the equation. So for your K, y value of the vertex, so y minus 1 squared is equal to the 4p, which is 12. So your p times x minus h, so minus 1. Any questions? All right, 4, write the quadratic equation given a focus of negative 1, 2, and a directrix of y is equal to 6. So it's already plotted. I have my vertex, which is at negative 1, 4. What's my value of P? 2. Your distance from your vertex to the focus, 1, 2. So P is 2. This opens down, so is it going to be a positive or a negative 4P?
Negative.
Negative. It needs to be a negative 4P. So negative 4 times 2 is a negative 8. So if it opens down, which variable is squared, x or y?
X.
X. So x, and then my vertex, x minus h, so minus a negative 1, which is plus 1 squared, is equal to the negative 4p, which we already calculated, negative 8 times y minus your h, which is 4. Once you got that, we can flip it. All right, last two. A coordinate grid is overlaid on the arc of the basketball shot. The vertex of the parabola is located at 7, 16. So your vertex is your highest point. So if you look at your graph, I know it's a little hard to see, like right here would be the highest point of the ball, which is going to be at 716. So my vertex is at 716. My focus, which is inside the arc, is located at 712. So over 7, 12. Let's just say it's like right here. Can't even see that. So that would be at 7, 12. If you need to sketch a new grid, you can. We know from the picture it's going to open down. So that means my x is what is squared. So it's the x minus 8 squared. That means your p is going to be a negative, so negative 4p times y minus k. So if this is my vertex and this is my focus, what is the distance between your vertex and your focus? 4. You can look here. 16 minus 12 is 4. So that means that P is 4. So a negative 4P would be a negative 16. Because negative 4 times 4 is negative 16. So my equation, just plug right in. So x minus h value of your vertex, x value of your vertex, which is 7. So x minus 7 squared. We've already calculated the negative 4p, which is negative 16. Times your y minus k, your y value of the vertex, which is 16, so minus 16. Any questions? All right, last one down here at the bottom. Carol was writing an equation of a parabola for her math homework. She was given the vertex point, the direction of opening, and the directrix. She wrote the equation, negative 2 times x plus 3 is equal to y minus 2 squared. Which of the following shows the information she was provided to write her equation? So I have my equation. We're kind of going to work backwards or figure out, with my equation, figure out this information. Now, looks a little different. We're used to the squared being on the left side. This time it is on the right side. It doesn't really matter, all right? Don't get confused. It doesn't really matter. I could switch this around. You could flip it if you really wanted to, where it is y minus 2 squared is equal to the negative 2 times x plus 3. So don't get messed up if it's flipped. So if we look at what's squared, it is your y. So if my y is squared, how is it going to open? It's up or down or left or right?
Left.
So it's going to be left or right. But because this is a negative, it's going to open to the left. So from your answer choices, we can cross off A and C. Now, given my equation, we can find the vertex is your HK. So remember, AH is with the X. Remember, when we're taking it out, it's the opposite. So opposite of positive 3 is a negative 3. And opposite of negative 2 is a positive 2. So your vertex is at negative 3, too. Well, if we look at our answer choices B and D, I can cross off D because my vertex is not correct. So it has to be B. Now, I know that we've already answered it, but if we wanted to even just double check your directrix, your negative 4p is negative 2. So negative 4p is negative 2. So to figure out what p is, divide by negative 4. So p is equal to 1/2, which is the same thing as also 0.5. So if we think about this graphically, so my vertex is at negative 3, 2. I know it opens to the left. So if P is 0.5, if it opens this way, directrix is this way. Well, P is 0.5, so it's going to have to be 0.5 here. So that X value, which is at negative 3, subtract 1/2, which would give you the negative 2.5 on your directrix.